What is thermodynamics? Thermodynamics is a branch of science which deals with the study of heat and temperature and their relation to other forms of energy. It applies to a variety of science and engineering topics such as chemical, physical, and mechanical engineering. This branch was basically developed out of a desire to improve the efficiency of steam. Application of thermodynamics. Here are some more applications of thermodynamics. Sweating in a crowded room. In a crowded room, every person starts sweating. The body starts cooling down by transferring the body heat to the sweat evaporates, adding heat to the room. Again, this happens due to the first and second law of thermodynamics in action. One thing to keep in mind, heat is not lost but transferred, attaining equilibrium with maximum entropy. Melting of ice cube. Ice cube in a drink absorb heat from the drink, making the drink colder. If we forget to drink it, after some time, it again attains room temperature by absorbing the atmospheric heat. All this happens as per the first and second law of thermodynamics. According to the law, heat always flows from a body at a higher temperature to a body at a lower temperature. This law is applicable to all types of heat engine cycles including Otto, diesel, etc. for all types of working fluids used in the engines. This law has led to the progress of present-day vehicles. Another application of this law is refrigerators and heat pumps based on the reverse Carnot cycle. If you want to move heat from a body at a lower temperature to a body at a higher temperature, then you have to supply external work. Removing heat from the food items in the refrigerator and throwing it away to the higher temperature atmosphere doesn't happen automatically. In the original Carnot cycle, heat produces work, while in the reverse Carnot cycle, work provided to transfer heat from lower temperature reservoir to a higher temperature reservoir. Air conditioner and heat pump follow the similar law of thermodynamics. We need to supply external work via the compressor to make this happen in the refrigerator. The air conditioner removes heat from the room and maintains it at a lower temperature by throwing the absorbed heat into the atmosphere. The heat pump absorbs heat from the atmosphere and supplies it to the room, which is colder in winters. Thermodynamic system. A definite quantity of matter on which we focus our attention for its thermodynamic analysis to study the change in properties due to exchange of energy in the form of heat and work is called thermodynamic system. The system may be quantity of steam, a mixture of gas and vapor, or a piston cylinder. Contents, definition, types of their examples, open system, closed system, and isolated system. System. Anything which are kept in consideration is called system. Surrounding. Everything external to the system is known as surrounding. Boundary. The thermodynamic system and surroundings are separated by an envelope called boundary of a system. Universe. Thermodynamic system plus surrounding equals universe. Classification of thermodynamic system. Open system. In open system, the mass as well as energy transfer may take place between system and its surrounding. Most of engineering devices are open system. Example of open system: internal combustion engines, air compressor, water pump, steam engine, boiler, turbine. Closed system. In closed system, the mass within the boundary of the system remains constant and only the energy transfer may take place between the system and its surroundings. Examples of closed system: pressure cooker, A rubber balloon filled with air and tightly closed, the gas confined between a piston and cylinder. Isolated system. In an isolated system, neither mass nor energy transfer takes place between the system and its surroundings. Example of isolated system: thermos plus the universe.